So we have this integral. We're asked to find the points of discontinuity and then use area to evaluate the integral. So we'll start with the points of discontinuity. A point of discontinuity is a place where if you're tracing the graph with your finger, you'd have to lift your finger to get to the next part of the graph. Okay? And points of discontinuity usually happen where we have a divide by zero problem, or we have a square root of a negative, or things like that. So x equals 0 is a divide by 0 problem. That's a point of discontinuity for this graph. And you can see it because I've graphed it right here using Desmos. Okay. You can see at x equals 0, your finger would have to lift to jump to the next part of the graph. And then they said use area to evaluate the integral. We're asked to evaluate the integral from x equals -1 to x equals 2. So here's where x equals -1. We want to find this area, which is negative because it's below the x-axis. And then it needs to go all the way to x equals 2. So this is positive. Okay, so this area down here, it's 1 across and 1 down, so it's a square. It's -1 in area because it's below the x-axis. And this rectangle over here, it's 2 across and 1 up, so it's +2. And if you add those together, you get 1. So that is this integral. It's equal to 1. Okay, so for this one I didn't have the graph, but we actually don't need it. We'll be able to see what shape this graph is once we do a little bit of rewriting. Okay, same thing, points of discontinuity. We have a divide by 0 problem when x equals 3 the way it's written. So that's a point of discontinuity. And then we want to find the area. I don't have the graph, but look, this is factorable up top. Because you could say that's -x squared plus 9, or you could factor out the -1. So if I factor out the -1, then I've got a positive x squared and now a -9. And that numerator is factorable, right? You could find two numbers that multiply to be -9 but add up to be 0. That's x minus 3 and x plus 3. So always look for factoring. If you got an x squared, think of whether you can factor it. And so we got an x minus 3 up top and an x minus 3 on bottom. Those can cancel. And we can distribute that negative sign. So this is the same function just rewritten. Okay, so this is a linear function. It starts at y equals -3. And then the slope's -1. So we go down 1 to the right 1. Or up 1 to the left 1. Up 1 to the left 1. So we should have a line like this. Come on. Okay, so the integral says find the area between x equals -5, which I'm not sure on my graph where that would land, so I'll put -5 over here, maybe we'll adjust it, and x equals 6. So we want to find this entire area. Maybe we'll have to have a little positive triangle here and then a big negative triangle down here. But the area between the curve, which is this straight line, and the x-axis is what we're asked to evaluate with an integral. Oh, sorry, I dropped my dx as I was getting lazy. That dx means with respect to x. You know, if there's two variables and you're evaluating just a single variable integral, that tells you what the variable is of integration. But that's a finer detail for later. Okay, so what we really want to know is where does this, if we don't have a graphing calculator, where does this graph cross the x-axis here? So this is the line, -x minus 3. You can find out where it crosses the x-axis by setting it equal to 0. If you solve that, you get x equals -3. So my guess was correct. We're going to have a little bit of area over here. So here's x equals -3. So we've got a positive area because this is above the x-axis. And this triangle is 2 across. And how many up? We need to know this y coordinate, right? So how are we going to get that without a graphing calculator? You could plug in x equals -5 into your function. If you plug in -5 in there, you've got -5 minus 3. That's 2. So this up here is at y equals 2. So the triangle is 2 up and then 2 across. So a triangle is 1/2 times base times height. So 1/2 times 2 times 2. So that's 2 for the area of the triangle. But we also have to add the negative area that we have below here. We just calculated this. We also need to know what's this negative area down here. And to figure that out, we know that this place is x equals 6 because that's the end point of our integral. And so this distance across is 3 plus another 6. This is 9 across, and it's going to be a triangle. So I'll start filling out the formula for the triangle. 1/2 base times height. We need to know how low it goes. So again, we need to know what's the y-coordinate when x equals 6. You can just plug that into your equation to find out the y-coordinate. You got negative 6 minus 3 equals negative 9. So this is 9 down. Oh, and I'll make that a negative 9 because this area is supposed to be negative. And so this is going to be 2, and negative 18 times 1/2, that makes negative 9. So you can subtract those two to make negative 7. So the total area for this integral is negative 7. That should be our final answer. Actually, I just checked. I did something wrong because the book got negative 77 over 2, which is pretty different. This is the crossing point, so that's 9. And then I plugged in 6. That makes negative 9. That's right. Oh, I'm stupid. I did 9 times 9 makes 18. I'm sorry. 9 times 9 makes 81. So this is negative 81 over 2. And so if you do 4 over 2 minus 81 over 2, that makes negative 77 over 2. Okay, so for some reason, 9 times 9 was 18 today. 9 times 9 is 81. Sorry about that.